Saturn is minus 200 degrees Fahrenheit. Storm season is well underway as
miles per
cloud
hour.
cover increases.
Storm warning for Jupiter.
With further
50-mile-long
south
frontal
will increase as winds in the Great Red Spot increase.
Red spot increased to 400
miles
miles per hour. Visibility on Io is dropping to 0. The radiation warning
And radiation warning forecast is at a
with
maximum
another
with
deadly
other deadly auroras.
65 of the summer dust storm on Mars. All regions of the planet affected. More bad weather on the way as this...
Alien weather, wild and extreme, rages through the solar system. But no one has ever experienced its fury until now. Storms from the planets are coming down to Earth. Our planet has its own dust storms sweeping into our cities and blotting out the sun. But a Martian dust storm would last for months and keep on growing until it had covered our entire planet. Our greatest hurricanes blow at 200 miles an hour, tearing cities apart in a matter of minutes. Now imagine a storm from the planet Jupiter. Twice as fast, it roars for centuries, devouring everything in its path. On Earth, an aircraft can survive a thunderstorm. But inside Jupiter, lightning bolts explode with 100 times more energy. And all this alien weather is about to give up its secrets in a laboratory called Planet Earth. A summer storm reveals the heart of the monsters boiling inside Jupiter. In the desert, scientists hunt down the mysterious forces that set a Martian dust storm in motion. And active volcanoes hold the key to the most beautiful but deadly weather in the solar system, on a planet where no human could ever survive. Our small blue planet shelters us from the violence of alien weather. But if we fall at the mercy of the ultimate storm, a storm from outer space, there will be no place to hide. We have been scouring the heavens for centuries, hoping for signs of life. And one planet above all has been the object of our obsession: the red planet Mars. The first explorers to set foot there will carry on the search, but they will face a deadly threat. Because what we have already found on Mars is not alien life, but alien weather. Mars is consumed by dust storms, blasting its surface at 200 miles an hour. And now scientists are trying to calculate the risks for the astronauts who will go there. Wes Ward is the chief of Mars exploration for the United States Geological Survey. Ever since Mariner 9 became the first spacecraft to go into orbit around Mars, he has been driven by the dream of a manned mission to the Red Planet. But his weather forecast is danger.
When our first astronauts land on Mars, they're probably going to have a pretty tough time of it. The first time we really got to understand what's going on Mars was with the Mariner 9 mission in 1971. We'd flown by Mars 3 times in the earlier 60s, but didn't see very much. We get to Mars with Mariner 9, beautiful spacecraft, working perfectly, all their instruments are ready to go, and we turn our eyes to the planet to see what we can find out. And we look down, and we see absolutely nothing. The entire planet is covered by one global dust storm. Well, all the geologists were terribly disappointed because they wanted to see what the planet was doing. But the science fiction part of my mind says, oh yeah, these are these great dust storms that we always have read about. And isn't this cool? Here you have an entire planet that's covered by one massive storm, and something fantastic has to be going on Mars. Sooner or later, and I hope a lot sooner, I'd like to see it in my lifetime, it's possible to get to Mars 20, 30, 40 years. And of all the things we have thought about when we're going to see on Mars, the number one problem we're going to have is weather.
In the Mojave Desert outside Los Angeles, a team of engineers prepares for a unique experiment. Using powerful fans, they plan to bring a Martian dust storm down to Earth so that Wes Ward can have the dubious honor of enduring Martian weather firsthand. Wes has a deadly serious scientific purpose, paving the way for future astronauts. On Mars, dust moving at high speed will place them in mortal danger. It's vital to know the effects Martian weather will have on both men and equipment. An astronaut's spacesuit is his life support system, his only protection from an alien environment. No one has entered this machine before. No one knows what Wes will experience until he steps inside.
When someone says to you, you're going to step inside a tornado machine, that gives you a reason to pause, I guess, early on. But I think most what we need to do is step out of the academic, allow something to happen, because very often that's how some of the best discoveries take place. You put yourself in a position to make observations, to make interactions. And if you're really lucky, not everything goes as predicted. There's that one other piece, that second piece, that third piece of something you never expected. You're on the way to discovery.
Here, and it's ready to go.
Let's go to Mars.
But Wes discovers that earthly weather can also bite. Desert winds have reached 50 miles an hour, making the structure unsafe. Work is called off for the day. But on Mars, a storm like this would last for weeks. For Wes Ward, Mars is a vision of the Earth as a desert world, where the dust storm is king. When Mariner 9 reached Mars, it was a whole month before the massive dust storm finally died down to reveal a lifeless, desert world. Summer temperatures rarely reach freezing point, and they plummet by 10 degrees when dust storms block out the sun. With no water and no life, wind and dust are the major forces shaping the Martian surface. Dust storms rule the red planet, and now scientists want to know how these alien storms are born. At NASA's Ames Research Center in California, they go to incredible lengths to simulate Martian conditions. A wind tunnel is coated with ultra-fine red dust. On Mars, millions of years of high winds have pounded the rock to a dust as fine as talcum powder. Scientists must wear breathing masks, but when the experiment begins, they have to leave altogether because the Martian air is 100 times thinner than the Earth's. the entire laboratory must be pumped out to create a virtually airless no man's land. But there isn't enough air pressure left in the wind tunnel to force a single speck of dust off the ground, even with a 60-mile-an-hour wind. Scientists need another Martian laboratory, the deserts of the Earth. And Steve Metzger, a geologist from the University of Nevada, makes an amazing discovery. It takes more than just wind to blow up a storm.
This is kind of a general wind blow. It's picking up a lot of sand, and it's going to definitely cover a wide area, but it's only taking it up a few dozen yards. It's obviously able to carry a lot of stuff. There goes my water bottle. Oh wow, I can just really feel sand bouncing off every surface of my body. Sand is bouncing along and it's picking up dust because it's eroding it and splashing it off the surface.
Steve thinks sand is a key ingredient, and the Mars wind tunnel shows why. The bigger sand grains bouncing along the surface help to raise dust into the thin but fast-flowing air above it. The effect of sand is crucial in explaining how dust storms can happen in the thin Martian atmosphere. And the final evidence comes from Mars itself. The Mars Global Surveyor spacecraft captured these pictures of shifting sand dunes. And another powerful force seems to be at work. The same spacecraft has been detecting strange fuzzy spots on the planet's surface, leaving long, dark trails. But there were no pictures from ground level until the Pathfinder mission touched down and Steve Metzger spotted something that NASA's own scientists had missed.
After the mission landed and I downloaded some pictures off the internet, used the right filtering and a little computer processing, you could see the strong column that's going straight up. It might go 1 or 2 miles up into the air, right against the horizon, showing up against a background of quite a bit of dust haze.
The tall, twisting columns are called dust devils. And our deserts are so similar to Mars that we have them too. Whenever dust storms happen on Mars, dust devils always seem to be present. They're also under suspicion on our own world. Because as dust storms rule Mars, they also roam the Earth. In the 1930s, the North American prairies were overrun by a plague of storms that lasted for months, and then years. The terrible hardships of the Dust Bowl days caused the biggest mass exodus of people that America has ever witnessed. In the long drought of 1983, Melbourne, Australia, was attacked by 2 million tons of dust in a creeping cloud 1,000 feet high. A desert storm in the heart of the city, trapping 3 million people on the choking streets. And in Southern California, a fast-moving wall of dust turned a busy highway into the worst traffic accident in American history. On the day after the Thanksgiving holiday in 1991, thousands of people were using California's Interstate 5. The surrounding farmlands are borderline desert, and this was the last of 6 years of drought, the worst on record. The soil in the fields had turned to dust, and on that day, the dust started to move. 164 cars and trucks disappeared in an all-consuming cloud of dust. None came out the other side. Officer Mike Brown, a helicopter pilot from the California Highway Patrol, was scrambled to the scene.
It seemed like a normal day. The weather here was clear. It was a little bit windy, but nothing out of the ordinary. When we got to the area of Interstate 5, most of the freeway was obscured from dust. It's just a complete wall. And so until we were approximately 50 feet above the ground, we couldn't see anything that was on the ground. It was completely obscured. The scene was almost surreal. You walk into this scene and you begin assessing damage. Vehicles are twisted, mangled, embedded in each other. It's like a battle scene, but it's in the middle of a dust storm.
150 people were injured in the dust storm that struck Interstate 5. 17 were killed.
I'm a native Californian. I've lived here for 53 years, all my life. I've flown in this particular area for 20 years. And to my knowledge, we've never had a phenomenon like this. The dust cloud went as high as 14,000 feet. And it was as if the dust were being generated from some type of a machine.
There seemed to be nothing different about the weather conditions on that day to trigger the Interstate 5 disaster. But Steve Metzger believes it's possible that dust devils may have played their part. Just as they helped to start global dust storms on Mars, sand can get dust off the ground, but Steve thinks that dust devils may finish the job.
Dust is actually very hard to move. In order for the wind to erode the surface, the wind has got to get down to the surface. And every surface has its characteristics as to how it drags the wind as it moves across that surface. We can see it by seeing how little wind is moving right across this surface. But the moment you get further up into the air column, the wind speed really starts to pick up and it gets to be pretty strong. This mast is measuring the wind speed at a whole bunch of different levels, and we can project down mathematically onto the surface to see how much energy is actually making it here. One of the ideas on how that is linked from the dust devil to the dust storm is that the dust devils are lifting up enough dust in a certain area to heat up the atmosphere, turn that atmosphere unstable, and really get some strong winds churning in it. Then those sweep down across the surface, raising huge quantities of dust and leading to the global dust storms.
Oh, they're perfect. Look at that. There's a real clear column right yonder. There's sand ejecta skirts on these guys because they're flipping out the heavier sand. It's perfect. It'll sandblast the car, too. That'll be nice.
Steve also faces being sandblasted as he joins the chase for hard evidence.
All right. This dust devil is really wide. It's got several parts to it. This is going to be nasty. Oh, 45 milligrams per cubic meter is kind of dusty. Oh, wow. It's hard to breathe inside those, too. Another one, excellent column forming. All right, look at this. This is great. This is a perfect day. Dust devils are able to just take whatever they can erode off the surface, and it's an escalator ride up into the sky, way above the area that normal wind whips up dust. And this is a calm day. There's nothing else going on except a gentle breeze, maybe about 5 or 10 miles an hour. Two big dust devils working away. That's where they're happening. That's where we'll go.
Steve wants to measure how much dust is being lifted, But the sandblasting effect inside a dust devil gives him two problems: getting in and getting out. Lance comes to the rescue, Steve's name for a specially adapted truck. Its 20-foot pole carries the instruments and takes the sting out of dust devil work. It's 2 o'clock in the afternoon, exactly the same time that dust devils spring up on Mars.
Dust devils can happen anytime you have a dry surface being warmed by a sun on a clear sky.
Off we go.
The surface heats up, the air right above the surface gets warm. This air is unstable, it starts to rise, especially if a little wind comes through and gives it a bit of a twist.
Are you holding on tight?
It's off and running, we've got a visible dust column, and the dust devil is started. It's trying to form up. It's about 50, 60 feet in diameter. Oh yeah, here it goes. It's slowly turning. Oh, all right, this is gonna be good. All right, baby, here we go.
Woohoo! All right. Dust devil number 1.
Probably going up about half a mile. Oh wow, it is tough to get in front of this thing. It is moving fast. Here we come.
Woohoo! Ow! Damn!
On Mars, dust devils like these can be 5 miles high and almost a half a mile wide. But even here on Earth, Steve finds that just a few can lift 9 tons of dust into the atmosphere in this small area alone. Over a wider region, that's enough to bring a monster storm to life.
The sun is beating on the dust, the air around the dust warms up. That can change the whole thermal dynamics of that section of the atmosphere. That can get regional currents going in the atmosphere, and that can lead to large-scale dust storms, both on Earth or on Mars.
Steve cannot yet predict dust storms, but he's beginning to understand their causes.
The dust storm that swept over I-5 may have started because dust devils upwind of it were feeding dust into the atmosphere, making that atmosphere unstable. And although it's also possible that a very strong wind pattern of a more conventional sense was responsible, dust devils can do that sort of thing, charging the atmosphere with dust, heating it up, and a regional dust storm results.
Once dust devils have set a storm in motion, no power on Earth or Mars can stop it. The Mojave Desert in California is scarred by the colossal blasting power of wind, dust, and sand. For 15,000 years, the wind has been grinding rock into these streamlined shapes called yardangs. But much larger yardangs can be found on Mars. The Global Surveyor sent back these pictures. 300-foot-high monuments, sandblasted into shape for over 100,000 years. Martian yardangs are carved by a maelstrom of dust and sand, moving at up to 200 miles an hour. Geologists like Wes Ward have seen what wind can do to solid rock. But he's about to find out what it could do to astronauts.
Once you get on Mars, if you're very unlucky, you might encounter some of these dust devils and Martian windstorms. And what that's going to do for us is start to move around some of this very fine sand and loose, fine Martian dust. So it could affect the operation of your suit, it could affect the operation of your rover, it could affect the habitat. Dust is going to very easily get into the airlock and inside the habitat, so we could start to face some biological considerations very quickly. But I think most off, I would be concerned about the wind simply blowing out there.
Dawn is the calmest period of the desert day. But Wes Ward's team of engineers have only a narrow window of opportunity before the landscape warms and the winds pick up again. The effects on a man of fast-moving dust and sand cannot be predicted. In the final tense minutes before sunrise, Wes ponders the possibilities. But the wind may be the least of his problems. A buildup of static electricity